There are a series of terminologies and words that you come across when reading the building code. These words and terminologies are important in interpreting the various sections of the code. And I will try to explain some of them now. We'll come across them during the entire semester. But just to review some of them, the terminology you will see when you're studying the occupancy and also types of construction, don't come across the words such as primary structure. Primary structure is the primary elements in which the building is being held up, and it is the skeleton of the building. And what the skeleton human beings have, the same skeleton exists for the buildings. And that allows it to function, move, be able to resist forces such as earthquake, wind, etc. Now you might have a steel structure, you might have a concrete structure, you might have a wood structure, but that will be considered your primary structure. The next terminology is bearing and non-bearing. When you have a soil or earth or ground and you place an object, if this is your ground and this is your object, this object has load because of its weight. So there is a weight, which that weight is considered a load. And that load goes down to the ground. So whatever happens in this element at this point of the object to the ground, that is where the load of the building gets transferred down to the ground. If you have a building, let's say you have a house, this house is sitting on a land. Obviously, you have materials at the roof, which has some weight to it. You have walls that have materials on them. They are plaster, they might be stone, etc. There is a weight to this. Same with windows and doors. There are windows that have weight to them, glass, frame, etc. All of that starts to transfer into the load. The structure plus material is called dead load. When people and furniture are moving in, this is, since it's a movable element, is considered live load. The design for the structure whether it is for the foundation, for the main skeleton, etc., has to take into account the dead load and the live load. Then you have wind. You also might have earthquake. So this design also has to take into account all the external forces. When you look at a building, you sometimes look at a roof. Let's say you're in a bus stop. And people are standing here. When you look at this, you see this roof and you see these columns. The weight of this roof is transferred to these columns. And these columns transfer them down to the area where we don't see, and that is below grade. And that is the foundation. And from the foundation, it gets dispersed to the soil. In this case, the column, which another word for it is post, is load bearing. The same if I go back to this diagram of this house. These walls on the outside that are carrying the load of the roof down to the ground are load bearing. If I come in and I'm looking at a building or inside of a space, let's say with a bird's eye view. So here's a bird's eye view of a inside of a space. And I've taken the roof off of it. The structure that was here, and I'm not showing it because I have removed it, relied on these walls on the outside to take its load down to the ground. So it is sufficient for this roof to stay where it is and be supported by these walls against all elements: earthquake, wind, dead load, live load. If I come in and build a wall inside, that I can create two separate rooms in here, but this wall has nothing to do with carrying the load down, then this is considered a non-bearing partition.